Right, so the first thing I want to do is remind you of our fraction properties that we talked about last class. And this is just kind of the general rule where when you have the same thing over itself, it crosses out. So this is just kind of like a generic rule, but it's just reminding us that if we have a C over C, and remember these are multiplying, it's A times C and B times C. If you've got a C over C, they cross out. Okay, so that means that the fraction is really just A over B. So if you break things into factors and then you recognize that they match, you can actually reduce them and eliminate them and reduce your fraction down just to the other parts, okay? So for example, we did this a little bit last class, 15 and 65. Well, we could divide, okay, or we could think of this as, 5 times 3, and this is 5 times, is it 13? Yeah. Okay, 13. Well, if you notice, since they both have a 5 on top and bottom, those 5s will cancel out, just like our C's canceled out. So our leftover is just our 3 over our 13. Okay? And so that's what we did kind of last class, where we were practicing with our fractions. But we also moved on into multiplying and dividing our fractions. So in this case, remember, whenever we multiply fractions, we're really just multiplying straight across. So if you start with a problem like this, you can actually think of it as just this monomial times this monomial all over this times this. Okay, so you can actually think of it as just this is one huge numerator, and this is one huge denominator. And when you do that, remember we talked about how you can reduce fractions early. So 5 and 10, those both divide by the number 2, we know. So if you divide 5 and 10 by 2, you get a 1 and a 2. And then the other pair that reduces is 6 and 2. So they both divide by 2, and you get a 1 here and a 3 here. So when we look just at our fractions, we are finding that we have 1 times 3, which is a 3, and 1 times 2, which is a 2. Well, now let's use our rule of if we have the same thing over itself, that we can cross those out. So just like C over C crossed out, now let's see what we can cross out here. Well, we have an X here. Let me use a different color. And an X here. So those will cross out. We have if you look here, we've got 2 Y's here and a third one there. So 1, 2, 3. These 3 will cancel out with those 3. So y to the third, y squared, another y is also y to the third, so those cancel out. And if you look carefully, the only thing we have left is just our x squared. Okay, so that's our final answer. We reduced our fractions, our numbers early, our coefficients. We canceled out anything that matched on top and bottom, and then the leftover is where we have our answer. All right, so we follow the same rule here, except we have to factor first, and that's a key. That's why we factored last class. Factor first. Okay, so if you look carefully, whenever we factor, we always look for our what first? Always, always, always. It's always our GCF. So if you look here, our GCF is x. So we're left with x plus 7. That's why you practiced it. And then here, x squared really just means x times x. And I'm writing it out because when you separate it, when you write it out, those actually will cancel. So these, let me use a different marker. These will cancel, and you're just left with the numerator and the denominator. So that equals x plus 7 over the x that we have left. Now, you cannot cross out this x and that x. You cannot do that because this is a group. It is a couple. You cannot split them up. If there's a plus or there's a minus, they come together. You cannot look at them separately. So this comes together So you cannot separate it. If it crosses out, the whole thing would have to cross out. Okay? So then again here, the first thing we do is we factor. That's why we've been practicing it. So the factor of this, okay, think of your x. Okay, what multiplies to negative 5 and adds to negative 2? That is negative 5 and positive 3. Alright, then this is our pattern. Square root each of those and we get x plus 3 and x minus 3. That's why we keep practicing factoring, because we need to get used to it. We got to move on. And then if you notice, in a pair, which ones cancel out? Well, this x plus 3, because it's a pair, will cancel out with this x plus 3, because it is a pair. So the leftover is our x minus 5 in the numerator and our x minus 3 in the denominator. And so those canceled out because the pairs were identical, so we could cross them out on top and bottom. So those are the two that we're left with. And then we follow the same rules. We just add in multiplying and dividing where we go straight across, but we still eliminate and cross out and factor like we did with these.